Welcome back. In this video, we're gonna try to compute this integral. So our function is sine of x plus cosine of x, everything to the power 6, and we're gonna integrate between 0 and 2 pi. This is a Berkeley math computation problem. It's a calculus problem, and I see that if we expand this sixth power here, we're gonna have to do a lot of work. We can do that. Yes, we can do that. And instead of that, I'm going to use something else. So I'm going to use, we're going to simplify this sine plus cosine. And after that, we're going to use a recursive formula to simplify this power here. Because the powers, when we are integrating the sine or the cosine or any combination, the powers are the problem. I mean here 6 or 8 or 12 or anything. Okay, so the first step is to write this function here. So this is sine x plus cosine x can be written as square root of 2 sine of x plus pi over 4. Okay, so to see that this is the right one, just expand this one here using the rule sine of alpha plus beta is sine alpha cosine beta plus cosine beta sine cosine alpha sine beta, and you will see that. Okay, and if I do that, I'm gonna have I to be the integral between 0 and 2 pi of the square root of 2 sine of x plus pi over 4 to the power 6 dx. So I'm going to take this constant, square root of 2 to the power 6, it's 8. So here I have this integral now, x plus pi over 4 to the power 6 dx. Okay, so now let's not worry about this, and let's remember that to be able to solve this one here, we can find a relationship. Okay, so this is what I proved in a separate video that you can find. If I call in the integral between 0 and 2 pi sine n x dx, so I have found that this one here is equal to n minus 1 I n minus 2, okay, and over n. Okay, that means I have reduced this degree here by 2, and with some coefficients that we don't have to forget. So I have in is n minus 1 over n in minus 2. So I'm going to use this recursive relationship for the sine to simplify this 6 power. Note that every time I get rid of 2 powers. Okay, so here I can write 2, 4, and 0. Okay, we're gonna come back to this angle here because here we have only x. We don't have x plus pi over 4. We need to take care of that. So here, if I can expand my integral, in is gonna be n minus 1 over n times n minus 3 over n minus 2 times n minus 5 over n minus 4 in minus 6. Okay, so this is the if we keep writing this recursive relation, okay, we're gonna get more terms, but I stopped here in minus 6, and we will see why. Because here, if I see that this integral, when n is 6, that's my integral. That's the one that I want to compute. Okay, forget about this 8 here. We're going to come back to it. And forget about this x plus pi over 4. We'll fix it. Okay, so when n is 6, every time I can get rid of 2 degrees. Therefore, if I want to compute the integral for sine to the power 6, I can just plug n to be 6 here, and I get 5 over 6 times 3 over 4 times 1 over 2, and I get I 0. That means the sine here is sine to the power 1 is 0. But let's not forget one thing here. I don't have x. I have x plus pi over 4. So I'm going to do something else here. So here I'm going to see that the integral 0 to pi sine x plus pi over 4 dx. So I'm going to switch to x here or y. So if I let alpha to be x plus pi over 4, I note that when x is 0, I have pi over 4. And when x is 2 pi, I have 9 pi over 4. 9 pi over 4. And sine alpha to the power something dx. Okay? And because sine to the power n. Okay? But since n is 0, all I have now is to integrate. I0 is just the integral between pi over 4 and 9 pi over 4 dx. This one, when I do integrate, this is just 1. I have 9 pi over 4 minus pi over 4, and this will give me 5 pi over 4. Okay, so now I can go to my integral here. So here I can plug in I over 5 pi over 4, and I forgot something here. I forgot the 8. We forgot the 8 because we didn't put it in the front. Okay, we didn't put it from the beginning. Okay, so here I can go and see that I6 is 8, 5 over 6, 3 over 4, 1/2, 5 pi over 4. Okay, now let's do some simplification here. So this one here, sorry, 9 pi. So this is 9. So this is just 2 pi. Sorry, this is just 2 pi. It's not 5 pi. I don't know how we get this pi. So this is just 9 pi, 8 pi over. So this is just 2 pi. I0 is just 2 pi. It's a big mistake from me. It's 2 pi. So this is just 2 pi. It's not 5 pi over 4. It's just 2 pi. So I'll write it again. 8, 5 over 6, 3 over 4, 1/2, 2 pi. So these two will go these two. These two, and the 8, 6 I can write it 2 times 3. So I have 4, 8, 8, and 3 with the 3, and 5. This is 5 pi. So my integral is 5 pi. Sorry about this mistake here, I didn't see. So here, that means my integral, I, is 5 pi, and this is the final result. Okay? So we make mistakes, and we are happy to correct them. Okay? So next, if you want to prove this one here, okay, you can use an integration by part and do it. If you want to see more, I'll post a video on this one. Okay, so this is Berkeley math competition question, and I think this is an easier way to solve. Okay, remember this formula here and this recursive relation. It might help you if you want to do the test. Okay, anyways, please like, share, and subscribe. Thank you.